In the 1960s, scientists observed something strange in the night sky. It shone like a star, but in radio waves instead of visible light. The redshift of the object's light indicated that it was much further away than any star visible to a telescope. Instead, it had to be an object thousands of times brighter than an entire galaxy. These objects came to be known as quasars. Quasars are by far the brightest objects in the known universe. At the center of a quasar is a supermassive black hole ranging in size from 100,000 to 1 billion times as massive as the Sun. What makes these black holes special is that they are constantly consuming material. In fact, the most powerful quasars consume 10 Earth masses each second. Despite this rapid rate of consumption, the matter that falls into quasars forms a queue as a spinning disk of material called an accretion disk. They range in size from 1,000 astronomical units to a couple light years across. The material in this accretion disk is attracted so strongly by the black hole that it orbits at incredible speeds. This causes particles in the accretion disk to hit each other violently, heating the material to billions, sometimes trillions of degrees. For reference, that means that 1 gram of accretion disk material from the hottest quasars holds as much energy as 20 kilotons of TNT, or enough to flatten over 80 city blocks. At these temperatures, a significant portion of mass is converted directly into energy. Between 5 and 40% of the mass falling into a quasar is converted into electromagnetic radiation, or light, which is more efficient than any known process of mass-to-energy conversion other than matter-antimatter annihilation. This is the source of a quasar's extreme brightness. What's more, quasars produce jets of material that are expelled at speeds that are a significant portion of the speed of light. The method by which the particles in the jets are accelerated to such high speeds is poorly understood, but it is generally attributed to strong magnetic field generated by the spinning black hole at the center of the quasar. When quasars are observed with their relativistic jets pointing at Earth, they're called blazars. Like most supermassive black holes, quasars exist at the centers of galaxies. However, nearby galaxies have a distinct lack of quasars. Since light takes a long time to travel in the universe, this means that quasars primarily existed a very long time ago. Back then, large clouds of gas coalesced into stars tens of thousands of times more massive than the Sun. When these stars died, they collapsed into very large black holes. Since the early universe was more compact, it was able to provide these black holes with enough mass on which to feed that they became quasars. Now, the universe is much larger and less compact, meaning that the amount of matter necessary to form a quasar being in one place is vanishingly rare. However, in a few billion years, the Andromeda Galaxy is set to collide with our galaxy, the Milky Way. When it does, the black holes at the center of each galaxy will merge. The chaos of stars being flung may provide enough matter to the ensuing black hole for it to become a quasar, birthing another one of the most powerful objects in the universe.